this podcast, the Net Zero podcast, is for the consultants, for the engineers, for anyone to do with anything commercial that wants to know more about net zero in their buildings. Some that don't understand it, and some that actually take it upon themselves to go above and beyond in reducing their carbon footprint. I'm sitting here with Martin Fahy, Head of Sustainability for Mitsubishi Electric, and Ben Buttle-Ross, who's a technical trainer at Mitsubishi Electric, for their answers, their approach, and how we can change our lives incrementally and in a big way in supporting and decarbonisation in bigger commercial and smaller commercial buildings. Hello, both of you. Martin, great to meet you.
Great, yeah. Thanks for having me. Yeah.
So, Martin, we'll kick it off with a bit of about you, really. So, Mitsubishi Electric, 20 years this Feb.
Yeah.
2004, you started. When you started in 2004, how had your role changed from head of... Well, were you head of sustainability in 2004?
No.
Okay.
Very much not, no. I started as a salesperson, working out of our Birmingham office at the time. Evolved into area sales management, building a team. And then gradually over those years, working with different teams in-house, marketing, our one-to-one sales function, PMD, we evolved this thinking around sustainability a lot more. I wouldn't say we were the first to do it, but I think we were very early out there doing it, probably getting on for 15 years ago now.
So did Mitsubishi Electric, the angle with sustainability, was it around 15 years ago when
That's right,
it was starting to become a thing?
Yes, very much so. We created a discussion document, really, maybe slightly grandiose. We called it a philosophy that we created called the Green Gateway, because we could see then that buildings' place in this transition, this lower carbon transition, was growing, was becoming more of a discussion point. And we as a business wanted to be part of that discussion. The strapline in the early days for Green Gateway was join the conversation.
Okay.
We knew then that it was going to have to involve a lot of different people at different parts of the supply chain. And I think that's what gave me a new sort of interest, as it were. And our senior team at the time tapped me on the shoulder and said, look, how about doing this full time, really? Because we really want to concentrate on this. So that was good, I think, that they gave that space and the ability to concentrate on sustainability all those years ago.
What does your role at Mitsubishi Electric entail, being head of sustainability?
So more recently than that was in what we call our LES business, creating that Green Gateway philosophy and discussion, and that evolved through various phases. But more recently, in the last 3 to 4 years, I'm concentrating on a branch level, looking right across the piece of everything we do as a business. So we're not just living environmental systems, heating, cooling, ventilation, which is what we will talk about a lot here today, but we're lifts and escalators, factory automation, automotive componentry, semiconductors, lots of other things. So I've been on a steep learning curve with that. But we are Mitsubishi Electric, so we're right there at that electrification of industry.
It's what you do, your electrification, right?
Yeah. So broadly, 2 things that I concentrate on is how do we as a business fit in with what the global business has told the world that they're going to do with regards to the journey towards
Are you
net zero?
Are you back end of businesses in Mitsubishi Electric? How do we reduce our carbon footprint? How do we implement sustainability in the business? Or are you also front end saying this is how we need to run things front end wise to contractors and consultants?
Very much both. That's the two pillars, as it were, really, which is how do we reduce our own impacts as a business? The global business has stated their aim about being net zero and where they're going to be. What does that look like for us as a UK? And I work with our Irish business as well. But then a lot of time working with and talking to other heads of sustainability in large construction companies, end user clients.
Is it a lonely place? Is it a lonely place being head of sustainability in a corporate business as such, with being the person that has to come up with the ideas, or is there a network of, with FN there's the British Institute of Facilities Management. Is there a sustainability arm where you can be part of a body and you learn from other people in sustainability roles?
Very much so, because there isn't just one answer to this. We're fond of saying that net zero is a destination but without a map.
Okay.
So we all know where we've got to get to from a net zero point of view.
Okay.
But how we get there, whether you turn left or right out of the driveway one morning, you've got different routes to get there.
Okay.
We're of a certain size. Contractors, I'm sure we'll talk more about, are key in this transition, really, about how we do this fairly and make the most of the opportunities ahead of us.
Okay. Ben, you've been on our podcast before.
We've had a nice little chat, haven't we?
I'm not going to go through your background, but I want to know what you've been up to.
Of late?
Yeah, what have you been up to, Ben? I really want to know what you've been up to.
So of late, we've been playing about with new technologies and different ideas. So we're just trying to think of other ways that we can communicate with customers as far as the training goes. So we carried on doing plenty of webinars. We're doing more hands-on training.
Okay.
That seems to be coming back quite fiercely in some ways.
Okay.
Yeah. So people still want to do hands-on, but we're still going to do lots of e-learning as well. So it's going to carry on.
Okay.
We've been playing about with virtual reality.
Wow. Okay.
Okay. Especially when it comes to some larger equipment that might be quite hard to get into a training room.
Interesting. Okay.
That's where we're heading at the moment.
That's where you're looking at. That's what's keeping you busy.
That's what's keeping me busy at the moment. Yes.
Ben, what does the phrase net zero mean to you?
So it's
what's on a personal and a technical training role, net zero.
okay. So from a technical perspective, it's about helping to educate the customers how they can get themselves to being net zero, how we're going to get so they're doing as much as they can, so that electrification route, so we can stop, not supposed to burning so much carbon.
Okay.
Every time somebody says, well, we've got a gas boiler, and that's an opportunity for them to improve, and help them to understand that route. The idea of going completely zero, it's very, very hard, and I think sometimes it's not always achievable in some ways, But what we can do is help them get very near to it, and then talk about how we can do a little bit of offsetting. So it's understanding that.
Yeah, well, that's why it's important to understand the definitions of chip in there. So it's a net zero goal that we're looking to achieve as a planet, as everybody on this planet, all the companies.
I know the phrase net zero is very much it's a phrase which throws up a lot of feelings.
I'd rather have zero, by the way.
Zero.
I don't want net zero. I want zero.
But your approach is very much educational, as in let's educate these commercial building owners, consultants, people that are looking at this with their buildings, and actually saying, well, for you, people need to be educated to know exactly what they're doing.
Yeah, again, it's about being solution providers. We're about providing a solution to a problem, and we just make it very clear what the problem is.
Martin, what does it mean to you?
So net zero, I'm very close to it as a phrase, I must admit. So it's easy for me to get into the long grass.
So you've had a few life adjustments.
Yeah, into the long grass about it. I mean, when we were conceiving of that discussion document that we called Green Gateway, the phrase net zero just wasn't used. It wasn't about at the time. It just didn't exist. So net zero technically is reduce as much of your operational emissions as you
Maybe I should step in.
can.
What is net zero for you to tell a commercial building facilities manager or someone that is in a position to say, we've got a lot of gas on site here and a lot of inefficient plant. We want to go net zero.
Yeah. So for them, there's a lot of discussion around what we're building new versus the existing infrastructure that's already out there. The stat that's often bandied around at this point is that 80% of the buildings that we will still be in and using, living in, working in, spending our leisure time in, will be, they exist today. 80% of those will still be being used in 2050.
Yeah.
By that time, mid-century, we should have reached this net zero definition.
Okay.
Which means driving down the energy we use as much as we possibly can. I think for net zero, what they're asking for is a 90% reduction in emissions,
Mm-hmm.
and then you offset those residual emissions. So that's why it's a net figure and not an absolute figure.
We like the absolute. There would
If
be.
we were absolute, that would mean we're not creating any more emissions of any description at all. Impossible. So we need to drive down as much as we possibly can, then offset. And the big areas of opportunity there, and this is known by government and it's known by their advisors into government, the Committee on Climate Change, is buildings and surface transport. So that's why you're seeing a lot of change in regulation and people self-starting to answer your question, really, which is they're looking at their portfolios and saying, well, I could be stranded here. We've done work on this around stranded assets.
Yep.
I could, what are the buildings in my portfolio that I need to invest in to keep hold of that are going to get us towards this
Well,
net zero
it's no
goal?
different. Most real estate, people that own real estate, and some of them are clients, the years of, after every 15 years you replace the windows or you replace the roof. Now the conversation is, well, let's look at solar. Let's sort the electricity out. Let's get the comfort cooling right. Let's look at the next 20 years for the building. But net zero and going green and reducing carbon emissions is now an active conversation with those that own real estate.
Yeah.
Because if you don't do it, your building becomes less attractive to those that want to work in a building which is highly efficient.
Exactly that, and you end up with a stranded asset. You can't sell it, you can't rent it. What are you going to do? Are you going to invest in it, or you end up selling it cheaper to try and divest yourself of that as a possible burden?
For me, net zero is about reducing emissions in a building. For me, I'm more of an overall approach kind of guy, meaning we are sitting here on a HVAC podcast. However, I see great, HVAC carbon schemes coming off gas, going electric, which have got poor windows, poor insulation. And when you actually look at the increased cost,
It's not the right way to do it.
it seems to be the worst approach
not the right way.
because we go into this realm of we're no longer producing carbon, but we're now increasing our electricity intake, and the building still isn't suitable for the equipment.
Still comes back to that lean, mean, green. Yeah.
Correct.
Yeah. What can we do to reduce requirements of the building? Then what's the most efficient bit of equipment we can use to do the job? And
Do you think that approach is a problem? Like Martin, do you think that's a potential objection? People are looking at the quick, easy approach to go in to reduce carbon.
Well, we've always
Not all. I'd say more retrofit, because a lot of new buildings now you have to have certain insulation grades to pass building control.
So we've always been behind the energy hierarchy approach of captured, as Ben says, both lean, mean, and green.
Yeah.
And that's, I don't see that changing necessarily. What's changed, and picking up on your question, I think, Jacob, is as an equipment manufacturer, our concentration has always been on, and will always be on, operational efficiency. If the piece of equipment is in a building for 15 years, and we can find a 1.5% operational saving, so it can deliver each kilowatt of energy that you're asking of it, but with less energy consumed, that works on its full lifespan all over those years. So that's a big part of what we will do, continue to do as a manufacturer. What we've seen is a shift, is that as new buildings become ever more efficient, better insulation levels, better quality windows, shading, orientation of how they're built, the whole shebang there, their load requirements are dropping, quite rightly, dropping quite a lot. That means you need a lot less of equipment from a company like us, because your peak loads are dropping right back, and that's a good thing. Existing buildings, we've got to increase their insulation levels, do things in the right order. Again, operational loads are dropping back. So that's created a concentration on what they call the embodied carbon now of the entire building and of the elements in that building, like ours, like the HVAC equipment. So we've spent a lot of time and effort in recent years on understanding and being able to communicate to our customers and the wider audience, whoever wants to know really, as to what is the embodied carbon of your choice of picking a heat pump, of picking a Losney, of a ventilation unit, so that you can look at this building as a finished article and say that essentially is a bank of materials for the future.
For sure.
So when the building may be 60 years life, but the equipment in it might have 3 phases.
So the buildings are being built to even retrospectively rebuilt, not for the next 10 to 20 years, but actually probably for the next 50 to 100 years, to say this building is now at a standard where it's built to consume less energy.
Absolutely that, yeah.
I think the bigger picture with, especially when it comes to engineers, Ben, we don't get that as such. We don't see that. I think engineers, we live in the moment, less bigger picture, because, you train engineers, and I'm sure you've had similarities to what I come across,
CapEx
So
versus OpEx.
Yeah, correct. And then also the approach, well, it's never going to work. Net zero will never happen. You're putting brand new efficient equipment in poorly insulated buildings, etc., etc. A lot of negativity. What do you see face on with engineers? Has there been a transition from? Yeah. Because you create amazingly efficient equipment, and engineers love efficient, reliable equipment.
Yeah, because they'll get
But
callbacks.
30 years ago, before my time, and I know you've both mentioned it, but 20, 30 years ago, I take it then manufacturers weren't all about being the most efficient. So
the efficiency was there. We both pride ourselves on the high efficiency. I think the driver now about being renewables and being efficient is actually the other big driver that's happening now.
So are you seeing a change in when you're training engineers, I'd say more keenness for the efficiency? Because, if I was training 10 years ago, it'd be more learning about the equipment. It wouldn't be so much of, is this equipment, this heat pump, it can produce 80 degrees or 85, because you do have a unit which produces 80 degrees. Your CHV 75?
Yeah, QHV.
Are you having engineers ask the questions? Because engineers don't usually ask them questions.
Well, it's funny because these conversations go around little circles now. So that I am having some of those conversations now, and it's quite often having this conversation of going, well, rather than saying, right, we can produce this nice high temperature hot water, for example, with the QHV, the CO2 heat pump. More the conversation I have with them is going, yeah, but why? Why are you going for such high temperatures? What are you using it for? And they're going, okay, we'll go back and we'll revisit that. Rather than just saying, what the customer said, they're realizing that they are becoming this point of excellence as being, I call them green warriors. I don't think they always like it. Yeah, but
which is really fair for Ben to say, because you do, you drive a fully electric car and you're doing your bit.
Yeah.
But you're also appreciating the fact that there are green warriors with an element of stupidity and ignorance tied into that. Yeah.
I mean, Jacob, if you think, this does come up in conversation, and I don't blame you for pitching it that way because it happens, but which is the caricature of, well, this kit isn't really going to suit this existing building because we can't get the heat out of it, because and if we do, it won't operate as the efficiencies that you're saying. But if you take a step back as to what are we saying there as an entire industry, what we're saying is well, it's okay to have a very inefficient building with a leaky envelope as long as I can keep pumping energy into it to offset that. That's not right, is it? That just doesn't sit right. We need to reduce.
Which is bananas. Because
it is. It's poor.
I come across that a lot.
Yeah.
I bet you do.
Yeah. The oversizing that went on to compensate for that. And, we're in a different place. Look, that got us to where we are now. And we're all here now because of the fossil fuel industry in the last 200 years. We are. I mean, and that drove progress for us all. Of course it did. So we're all part of that. But we're in a different place now. We're of a generation now where we understand that we, as humans, are having an adverse effect, right? We're clever enough to have done this, and it's created this progress, but it's had consequences. We now understand what the consequences are, so we need to look at a different way.
Do we think that the consequences could have been caused because this net zero approach has been pushed too hard, too quickly? Because I know the media jumped on, I'd say the last year or two. I'd say the last 6 months it's calmed down, but the last few years, there was a huge push, which is great for the economies of the world, et cetera, et cetera. But with that, you do create these green warriors because,
Yeah, you're going to have...
I never forget the Instagram post of a music festival with 20 Teslas being charged by diesel generators. You know, if I was true to my word for reducing my carbon, I'm not. You know, if you need power, you need power. But a few people would say, "Well, I'm not doing that."
No, and everyone packing up and leaving all their rubbish,
you know,
and all of that sort of thing.
But maybe there is a.
Think of my initial statement here. We're on a journey here with this, so we know the ultimate goal, which isn't that far away in the scheme of things, 2050. So we as a business have said, right, we recognise our place as a global business in this. We need to be defined as net zero by 2050 at the latest across our entire value chain. So that's the huge amount of flow of materials, skills, everything that flows towards the piece of equipment being made. And then there's the downstream effects of that piece of equipment on the other side. So big piece of work there. So we recognise that as a business. But at heart as a business, we're a manufacturer. We're a manufacturer of solutions. We're talking about heat pumps a lot, quite rightly. So we've recognised that and said, well, actually, we feel we can move a bit quicker at the manufacturing and the built environment end. So our stated aim there is to say, well, we'll be net zero by definition across that portfolio, manufacturing and property, by 2030. Now, that's a different proposition. That's 6 years away. That's a whole different rate.
But as a commercial building owner or someone that is an FM in a building, being pushed or pushing too hard to come off gas and not looking over the overall picture, how, you know, what would you both say, maybe Martin, you first, in regards to how could you tweak your approach instead of just saying, let's rip out a load of boilers and put in air source heat pumps? You know, what do you think would you say you need to get in touch with an energy consultant or someone that has been involved with this? Because you do have, we come across it, and I know there are many people out there that are an FM in a building, and now they're being asked a simple question: you need to reduce your carbon loading. Crack on, and then it's what do I do? Yeah.
So we understand that as a business, I call it a sphere of influence. We have a sphere of influence in the contracting base that we talk to and work with. Why we're delighted to spend time with the likes of you, Jacob, on these sort of forums is to create that discussion and create that collaborative approach to how we're going to rise to this challenge. Because we have some of the solutions as a global business. The contractors are the ones that are actually going to have to physically make the change, take the equipment out, make sure it's handled properly.
The challenge we have as contractors, though, and it's what we face as engineers, is doing carbon schemes, net zero carbon schemes, in buildings which are leaking.
Yeah.
So it's a case of it's like banging your head on the table and sort of saying, this equipment you've got in is running at 75 degrees, your CAHV unit. However, you're saying, and as a manufacturer, you're saying, well, actually, you don't need it running at 75 degrees because your building should be a lot more airtight. And we should be running nearer 45, 50. So, which I love your analogy because it's something that I didn't really look at it as, the energy that the building is consuming. Because at 45, 50 degrees, the building, if it's insulated, roofs, etc., it is actually, you're putting less into it.
The cleanest and cheapest unit of energy is the one you're not using. Yeah. Right? It's as simple as that. But you don't I call this as turkeys voting for Christmas, really, which as a manufacturer, because you do all of those things right, you're going to need a smaller box from the manufacturer,
That's it.
us or anybody else. It's the right thing to do. We said there, and that was another phrase we use, I've stood up in front of many rooms internally and externally and said, look, we've got to live by what
rather than the manufacturer selling as many boxes, you're actually saying, well,
it can't be right to say, well, it's a leaky building, so let's oversize by 30%.
Which you have to do. You have to do if other things haven't been done.
That can't be right. Whether it's a gas, even worse, if there's a gas supply coming in and you're just wasting 30% of it because you didn't bother to plug the gaps in the building. That it's criminal, isn't it? We can't be doing that anymore. We have done it for years. Yeah. That doesn't work anymore. If something can be electrified, then that's what the scientists are telling us to do because we can do it now. So therefore, the rate of change can happen now. And heating, huge amount of emissions come from heating in the UK. Buildings as a whole are around, depending on the measure you look at, 30 to 40% of all emissions come from buildings. Another third.
I think it's about. Is it not nearer to 50%?
I should say, it depends what figures you look at. So let's call it 30 to 50%. And we'll put the
a
range
lot.
in.
There is commercial buildings are
Yeah.
which is something that I've learned recently. They're a massive.
Yeah.
That most 30
Another
50%
area
in the
is-
UK is a pretty big number.
Another area is surface transport, which is why the concentration is on regulation and change. We might feel as an industry we're being unfairly targeted, if you like, but no, it's because we can have such a positive impact at the rate that is needed. As I say, 2050 is around the corner in the scheme of things.
In that case, are you having these kind of conversations with your customers when you say, look, Jacob, can you sort out my solution here for this office?
We're unfortunately on the tail end. We're on the please quote for. So we quote for and we submit value add designs, which are more efficient with the engineering switched on approach. Because unfortunately, although we're talking about buildings consuming less, sometimes consuming more with cheaper equipment costs, in my opinion, is a better solution. Instead of having 10 items of plant, having a cascade setup, which has only got a coefficient of performance of probably 2, and that's a 4-pipe chiller, and then from 40 and then bumping it up to 80, that will cost a quarter of the cost. But my angle with that is your building's leaky. What's the point of trying to get to 40 to 50 degrees? Because it won't work. But there's a fine line of giving too much opinion and too much common sense before they tell you to shut up and go away.
Well, Jacob, it'll work.
It will work, yes.
Right, it won't not work.
But, well, you just
your
said...
COP of 2, that's comparing with your COP of 0.9 for the gas boiler. That
So it's double, it's cheaper to put in. However, what you said about
But there's a bigger reward, isn't there, at the end of it? So I wouldn't want to stop at a COP of 2 by any measure.
No, of course.
There's a lot
but
more.
what you've said, which I think I'll probably have to personally look in, as in adjust my thinking blinkers, I think it's the engineering hat I usually wear, is look at the bigger picture. If you've got plant which is only producing 50 degrees and it doesn't work so well, it's almost forcing the hand of we need to start insulating some roofs, insulating some walls. We need to, rather than, don't worry about it, we've got 80 degrees of hot water from our chillers.
And we probably haven't helped ourselves by making equipment that's got massive amounts of variability.
You haven't, but...
You know, they got it kind of wrong. Fitted the kit, right, okay, now we've done this glaze.
Again, that could be an effect of net zero being pushed, though, because if you're saying we've got boilers that need to be replaced, we've got 75 degrees of boilers, we need 75 degrees of hot waters, let's use a heat pump which creates 75 degrees. That is a quick fix solution. But in the bigger picture, it doesn't stop the building consuming less energy. It actually just replaces, but you're reducing your carbon emissions for the building.
Yeah, so we have a situation now where, remember what I said about if something could be electrified, then electrify it. Heat is the big one. Surface transport is the other one, which is why you're seeing lots of regulation and government pulling lots of levers in that regard. So, but the situation we have at the moment is if you go fully electric versus burning stuff, burning gas, a finite energy source with releases lots of carbon, your actual run cost at the moment, with the way energy prices are pitched, you could see an increase in your energy prices. So you've done the right thing. It shouldn't be the case.
It shoots to my design, but my other factor that I haven't mentioned, it costs a quarter of what the 50-degree solution is. So the question is if energy does continue to rise, electricity continues to rise, my solution in probably 8 to 10 years, yes, it wouldn't be valid. But then a lot of people are saying, well, let's actually invest now with the 40 to 50 degrees and we'll worry about that. We've invested the money now. And then if they're forced to do the roofs and they're forced to do the insulation, in the bigger picture, it works. Whereas my design, unfortunately, I'd probably say is probably a 10 to 15 year solution.
Remember, my cheapest, cleanest is the unit of energy you don't use. So you should always be looking to use less. That's the top of the bottom.
So talking of equipment.
Actually, I'm just going to stop you there because I'm rather intrigued because my experience of you is I think people listen to you. So I'm surprised that when you go and see a customer, you can't get them to think about the idea of being able to reduce,
It's
making it more lean to start off with.
the challenge we have is consultants. I believe that the UK is not geared. The you use the word education.
Okay.
Consultants are not educated correctly. A lot of consultants haven't done many net zero schemes, and we're coming across consultants. We've come across probably 4 in the last 12 months, which it's their first scheme, and their solutions don't really make any sense, but it does work. And in the grand scheme of things now, looking at a 20 to 30 year window, their scheme actually is pretty okay. Fitting DX units and then replacing DX units is actually a low cost way of doing things. For me, it's I don't like increased maintenance costs. I hate it, and that's just a service and maintenance engineer in me. I think that if you replace 2 boilers, you shouldn't put 20 items of plant in. You should look at doing 2 bigger bits of equipment. But every building is different. So I would say that consultants are less, they need to be more educated. Consultants are highly intelligent blues, they're really clever people. But we've always had this battle as engineers and consultants, and it's always, there's that area which...
Oh, you're right. There's been those and
for years.
And I bring in a third group of people, which is the architects as well. Which is the architectural vision, the engineered solution, versus then when you guys come in. And I think you mentioned earlier about being at the end.
We get asked a quote,
and that's not, and that's something I think we realised with Green Gateway and with other things that we're doing over the years, is to bring your end of things earlier into the conversation.
Yes,
we've certainly worked really hard to take ourselves higher and higher in the decision-making tree, and I'd like to think anyone who's worked with us for that period of time and been in our partner scheme for that period of time will see that we've taken them with us higher in that decision-making tree as well, because the input that you can give at that earlier stage is vital. It always has been, let alone now in a lower carbon world, about how can I deliver this product in the best way possible for this building. So we're always pushing to bring the contractor end earlier and earlier.
The challenge
into
which
the
we
discussion.
also have to that is we have many manufacturers, and they all recommend different things. And this is, again, where we're in this individualism of manufacturing products, where everything is so different. You do a product with a certain gas. Someone else does a more efficient product on a worse efficient gas. Should we use chillers with a higher GWP with better efficiency versus a lower GWP refrigerant with worse efficiency? So there's so many push and pulls, and that's why I believe that we've been this net zero the last 2 years has been pushed too much, because we're not all singing off the same hymn sheet. And I think we should. Ben, just going on, because we touched on solutions. If I had a building, 4-story building, 3 years old, pretty well insulated, I kind of feel like I know what your answer is going to be.
Okay.
What is your perfect electrification setup?
So offices.
Yeah.
I still like VRF.
Okay.
HVRF would be really nice.
And hot water.
And hot water, yes.
So are you saying VRF for the lot?
You can do the whole. If you depends on the amount of hot water on about here.
What would you do?
Well, I still loved it.
Here's a set of
ages
keys.
ago.
Ben, you do the design.
I still prefer the idea of the way we've got a VRF system. We're doing heating and cooling in that building, keeping that customer nice and happy the way they need to be. Yeah, and having the renewables idea that's still there, and then putting the heat pump, the PWFY unit, which goes with the VRF system.
Is this the comes off a branch selector box, and then you have an individual water heater?
It's where the first versions basically of the Ecodan really came from.
What's the max kilowattage from one of those units?
10 kilowatts.
Wow. Oh, and then it has a built-in electrical heater to top it up to.
No, it's got a little cascade circuit in it, so it's got from one refrigerant off to R134A to get the higher water temperatures.
And does that work on HVRF?
It doesn't work on HVRF, no.
So on conventional VRF?
Yes, on conventional VRF, it does, yeah.
Okay, so
my what I get excited about is because that means when you've got that period in time when you're doing some cooling, rather than taking that heat out of the building and producing hot air outside, I move it and put it into the hot water. That always seems like the most fantastic solution possible. Is any form of HVAC is, and air conditioning is energy movement. That's what we do. We're energy movers. That's what we're professionals at. Yeah. So let's just move the energy somewhere we can actually make the most of it. And there's nothing new within refrigeration, is it?
No.
It's just getting clear about it.
I mean, I, as I say, 35 odd years been doing this now. So, a heat pump to me, when we initially talked about heat pumps, was a system that can heat and cool.
Yeah.
That was what a heat pump was. That was what I was taught back in the day. When I speak to a layperson, which isn't any of us, hopefully, or any of your audience, but when I speak to a layperson, I say there's sources of heat. I draw 3 squares on a piece of paper. There's sources of heat, naturally occurring sources, air, water, ground, what would have historically been a waste, a waste product that we wanted to get rid of that heat. Over here, square number 3, if you like, is your sinks. You've got a demand for heat over here. As I've already said a couple of times, huge demand for heat.
So your
in the
drawing
UK.
is the your
It's
shifting.
three squares, sources of heat, natural, waste, wherever heat exists, the room next door, from a VRF point of view. So requirement for heat, in the jargon, a sink over here. The thing that joins those two together is a heat pump. A big one, a small one, an air source one, a water source one. It's a heat pump. It's an electrically driven device, so it buys into a future greening of the grid. It's the only bit of kit that can do that. No other technology can do that. So every year that it's in, and the grid gets greener and greener, it pulls that greener energy and converts that heat, upgrades that heat. So that's what I draw, is the 3 squares.
Okay.
Source, heat pump, sink. And the heat pump is the item that makes those things deliverable. That's known by Committee on Climate Change and everyone else. That's why they're saying, if you can electrify it, then do so.
So a heat pump, a heat recovery VRF, then, for those that don't understand what heat recovery VRF is, could you just in a few words, how it works?
Okay, so heat recovery is just allowing you to change around where your condensers and evaporators are. So you've got multiple indoor units, some of them acting as condensers, some of them acting as evaporators, and they can change roles. So the idea being then is I can heat and cool areas simultaneously off the same outdoor unit.
We've got ceiling units, wall-mounted units.
Yeah.
Are you suggesting if you had a heat recovery VRF unit, you could have a ceiling unit and a wall unit blowing out cold air, and then we're actually going to put one of the units in a hot water cylinder, and then that will get hot, rejecting the heat, and we'll be cooling in the summer. I see. Okay, interesting. So that's your favourite option.
Been doing it for 15 years, so that's where the first ones came from. The idea, and then the whole idea of doing domestic and then doing larger commercial kind of was all add-ons afterwards, wasn't it?
So 2-pipe heat pump chillers. Just a brief, what a 2-pipe heat pump chiller is. Just a conventional chiller.
So normal chiller, we're just taking energy from outside, bring it indoors, or vice versa.
So that's done by a fan. So if you've got a heat pump chiller, you're ejecting the cold air. You're not resourcing it back into the building. And if you're using it for cooling, you're then dumping the hot air out. Okay, so what seems to be more and more popular now is, which we've only, believe it or not, I've only got involved with these for the last couple of years, is 4-pipe chillers.
So that's basically bringing the two functions into the one box. So you've got a system that can both heat and cool out of the same box. So
instead of dumping that hot air or cold air to outside,
that's right.
You're saying I'm going to put it in your cylinder, and you're going to make the cylinder really cold. You're going to put water across it and make it really cold.
So you have another heat exchange circuit within that. And it
goes back to your drawing
system.
So we've got heating.
That's right. So you've basically got 2 heat pump circuits within the one box, and then it can move energy within that and supply. So traditionally, you would have a 4-pipe fan coil system, 2 cold pipes, 2 hot pipes. These systems can do that out of one box, but give you the ability to do some heat exchange within that box as well. So you should, proper design and building in balance, everything, fair wind, all of that, you shouldn't be rejecting anything. You should just be moving that.
So
heat around in
again,
the building.
although
Design's critical to this, by the way.
So you've mentioned again, as a commercial building owner or an FM, your building should be designed to consume as little energy as possible.
Correct.
But the other section to add to that is actually you potentially want to be looking at equipment which reuses as much energy as possible.
Absolutely.
Rather than putting something in there which, although it creates less, it reduces your carbon footprint and your building is using less energy, you're not reusing anything. So when we use the word renewable, a full pipe and your heat recovery are two products which allow the buildings to reuse or renew the energy they've got.
And they usually, it's interesting because the full pipe chiller was what the PURY system, the R2 system, the VRF heat recovery, that's what we went out to market to take away. That was one of our aims.
Was this your water source unit, water to water on it?
No, this is the divisional VRF systems. Was trying to take the full pipe system and bring it over to DX. It's interesting is how it's all come around full circle, which we've seen numerous times in the industry. Yeah, things do come around in a circle. So yeah, we're involved in full pipe chillers now as well. So it's
you mentioned design is critical because design is always critical. I have a gripe with this, and we've spoken about AI before because we're talking about efficient products, and we've gone through it. But one thing which throws this all out the window is control.
Yes.
Because these efficient units, if they're not controlled properly, you're actually creating more energy than you need.
Yeah.
So, have you got a solution for or are there solutions for people turning units on 30 degrees and then leaving them on for a week when they go on holiday and they come back? Oh, my office is hot. For me, AI can step in and say, whoa, you need to turn this off. I'm turning it off. Is there a solution for control?
We are looking at.
I mean, it'll be cloud. Cloud will be the way that you'll see things shifting. So we're doing that domestically. We're doing that commercially.
Do you think the cloud will be run by AI one day?
Well, think about AI as just being a way of doing lots of number crunching, not Terminator. Yeah.
And but it does make decisions. It can make decisions.
Making decisions based on lots and lots of information.
Okay.
Yeah. It's just doing the drudgery, hard, horrible job of sitting there crunching its way through numbers and looking for patterns. That's what AI is there to do, pattern recognition. Yeah.
But again, Jay, it's back to the original point. It's been ever thus, hasn't it? If you went off on holiday and left your boiler going on its 2 cycles of heating in the day, you've wasted all of that as well. So
in a commercial building, though, there is more potential for waste.
Of course there is, yeah.
Than my domestic. I don't have a domestic. I have a heat pump.
And we recognise this all those years ago back in the Green Gateway document. I mean, you could test me on it. Someone will look it up. But and we had monitor and control within there. You can't control what you're not measuring and what you're not monitoring. And it was all about. We used to talk about fit and forget back in the day.
Yeah.
Fantastic.
What a great saying that was.
Great saying.
Fit and forget.
Fit and forget. Put it in. It's so good.
You don't need to worry
about it. Don't worry about it. Those days are gone now, really. It's essentially we're in a world now where you should fit it and watch it constantly. Every second of every day. Does it need to be providing that amount? Can I drop the set point down? Can I change my mode over? Can I switch off completely? That's where we are now. Watch things like a hawk. So control AI will be instrumental into that. We don't know where AI is going to go. I'm far from an expert on it, but it has a logical place to play there, which is what Ben's saying. Gather all of the information, watch what the weather's going to be like.
It's unbelievable you say it because I'd say the last 10, well, if we go back to sort of 2017 and then went back 10, 15 years, because I'm a fit and forget. That's my approach. Yeah, I only put things in which I know will last for many years. However, I'd say 70% of the people we come across now, they want data, they want stats, they actually want to see things, and they want results produced.
You told me it's going to be this efficient. Show me.
Yeah.
And it goes back to it goes back to the joke. What was the joke, Martin? How do you know if somebody drives a Tesla? They tell you about it, right? But you speak to someone that has a Tesla and they are doing great, along a certain number of miles on a certain charge. They've got the data to show you, rather than buying a fit. Fit and forget doesn't work with a Tesla.
What you've done there, and we find this with people. So domestic heat pumps, you've got your classic adoption curve. Like for any technology. So the early adopter stage for us, because we've been talking about domestic heat pumps for a long while now with the Ecodam product, is if you were an early adopter, in our experience with that, certainly from what I was understanding in the conversations I was having, was you fell broadly into two groups. You were a self-builder, in which case you were building your forever home. You were engaged in everything. Your countertops in the toilet that you were going to have, everything to the finite detail. Your heating, you didn't put gas or oil in. You went with a heat pump. Or you were a local authority tenant or housing association tenant, and they were, and still are, rolling these out, investing in their estate. You're on a different income stream, fixed levels of income, and they were doing that for the benefit of improving their estate, but also improving the lot of the people who experienced that.
For sure.
So I had this discussion with a colleague recently as to whether or not we're out of the early adopt stage. I think we're now into the very much the Mr. and Mrs. Jones 22 Acacia Avenue side of things, which is a whole different discussion.
So every year, I agree. So we do a home building show every year at Farnborough. We did one in January. This is our annual show. And we've been doing it for 4 or 5 years. 5 years ago, I can tell you now, homeowners that were renovating and building houses, they were not bringing drawings to me saying, we're looking at an air source heat pump. It was, you do aircon? We could do with some aircon. Yeah, let's do aircon.
So air-to-air heat pumps.
Air-to-air. Asking for. Air-to-air. But they wanted it for the cooling.
Yeah.
Last year was probably the first year where people were asking if we did heat pumps, and there were some heat pump companies there. Yeah. This year, we're having a heat pump. Yeah. Does it work with a heat pump?
Yeah.
Do you do mechanical ventilation?
Are you getting people asking now about air conditioning just for the heating side of things?
Yes.
Well, good.
First year, man. First year where they're saying, but they're a strain of person, and I love that strain of person where they've done so much research and they've gone, I'm looking at a three-way multi-split for heating 2 bedrooms and a living room, but I'm not sure about the hot water. And I'm like, I feel like just giving them a massive high five. You need to go with us.
That's the most efficient way to do it.
Because it's like, yes.
I can work with these people. Yeah.
But this is the first year that I've had it. First year we've had it. And also with air source heat pumps, air to water.
It's been a real change.
It's the first time they've gone. I know there's planning laws and now people have to have 2 forms of renewables, usually solar and heat pump. But now people are saying, I'm having a heat pump and I'm looking at heating an additional room or cooling additional with air to air. So that, the beginning phase, we're now on the stage where people understand that we're going to have an electric heat pump.
Yeah.
But on a commercial scale, we're not even on the. I don't even think we're in the beginning stage. That's from my experience at the moment. There might be someone that's more of a travelled man or woman where they've been involved in this space for the last few years. And they would say, well, now it's adopting. But from what I've seen, it's still very much go to a consultant, do the recommendation. Do we do that? Do we not? And it's very much sitting on the fence.
To be more or less travelled than anybody, but I disagree. I think we're very much in that main body now of how do we create these spaces for people to live in, but equally for people to run a business.
I would probably say,
profitable.
Martin. I'd probably say though. Sorry, Mike. Not so much of it happening. I'd probably say more on the solution. So with residential, you have air to air, but you have air source heat pumps. The air source heat pumps, we're all on the same hymn sheet. If you talk to any manufacturer, if you want to do hot water and heating in your home and replace gas and reduce your carbon footprint, you're using an air to water heat pump. Commercially, there are so many different options. Yeah. I don't think we've all got that adoption of going VRF or going heat pump chiller or using, solar thermal. So it wasn't so much I was saying, no, we haven't adopted, because 100%. Most big businesses and small businesses now are going, how can I reduce my carbon footprint and how can I get my building more efficient? But I don't think...
When the solar thermal isn't, but all the other options you talked about there are heat pumps. Yeah. Right? They're electrically driven devices which are moving heat around on a building scale, on a, ambient air scale and in and around buildings. Then what we're also seeing now is developments where your heat requirement is more dense, so more built-up areas and more diverse requirements for heating and cooling. So the cloud that we all rely on for our computing and our phones and everything now is not some ethereal sort of misty thing.
To keep that cloud in the sky
Exactly.
requires a lot of...
It's buildings with racks of data processing in them, and those are being brought closer and closer to where that data is needed. Sort of a nodal.
You've probably got an answer on it, Ben. I haven't been involved with these schemes, but
it's a networking scheme.
Where does that heat go from data centers? Because I feel like a lot of them are just using air-cooled chillers or air-cooled VRF. Because there is a lot of, maybe it's a conversation for a data consultant, but they reject a lot of heat.
Oh, they do huge amounts.
Yeah, and but they're looking at community schemes. That's what they're doing.
As in using data center heat rejection to...
that's definitely not a new thing. It's been done quite a few times.
So it's an expansion out. So it's my 3 squares thing. So, we can look at one building with one roof being your home, ambient temperature, grab that heat, bring that in. Expand that out commercially, 20 rooms in an office building, someone cooling, someone heating. So we're moving heat around that building. The next step is this building is a net exporter of heat. It's a data center.
Yeah.
This building, your community center down here with the swimming pool in it, is a net consumer of heat.
Yeah, of course.
We join the two together. So that's network schemes, lower temperature network schemes, so that you can move heat around a community. And again, no surprise, it's a heat pump. That's the technology that's going to transfer.
And also, you can use a heat pump made to do a little bit of top up as well. So it could be a case of, right, what I'm going to get from the data center, I'm getting like a constant, say, 35, 40 degrees. By the time it's got to the rest of the community, it's lost down maybe 5 degrees. It's not high enough temperatures will do what I want to do. We can use a heat pump, a water-to-water heat pump, to bring that temperature up to something more usable. And we're doing a little bit of work, not a huge amount of work, therefore making it more efficient. I like getting involved in ones like that.
There seems to be excitement behind it because there's a lot of energy being consumed, and as you just rightly said, consumed, which you can transfer from one box to the other.
That's right. Yeah. What would have historically been a rejection thing, we've all fitted them. We've all fitted the cooling only 100% rejection. The problem I've had to overcome as a company here is the heat load. Else these servers are just going to fall over. So you grab that heat and just rejected it to atmosphere. The step up from that is, well, I've got some heat now. What shall I use it for? Hot water, the swimming pool next door, the school next door, whatever. That's heat is the valuable thing here. Ben mentioned it right at the back of the beginning of this. We're in the business of moving energy around. This happens to be heat energy.
You're Mitsubishi Electric, an energy moving business.
Yeah, and you are too.
Yeah,
It's what you do. Sorry.
At your end of things, that you make it happen. Actually, in that, when it comes down to it, it's you makes it happen. Install it properly, look after it properly, and it will work properly.
There seems to be a need for a net zero maintenance. The UE of SFG20, which is like a maintenance standard by SIBSI. Maybe there are changes, but I kind of feel there needs to be a net zero on our equipment, the way it needs to be installed. Because unfortunately, again, I don't think the gripe stands to manufacturers, but if I buy one of your great E-Series products and we install it terribly, and I know it happens with residential, but I don't want to go down that line because people start jumping up and down and have their different views and things. But I think there should be some kind of maintenance standard to work by, even an installation standard. So Mitsubishi Electric, you've got an online. Is it a committee?
Well,
who is it for?
So we as a business, I think we were very early, if not the first, to establish a partner in arrangement with the contractor base.
So it's for contractors.
Partner program.
Yeah. Okay.
And what we've done is that's evolved over years, the partner program. And our latest iteration of that is what we call Committed Carbon Reduction Partner.
Okay.
And the thing I mentioned earlier is that sphere of influence and collaboration. We have a certain sphere of influence in that we work with contractors, consultants, architects, the whole gamut of the supply chain about a solution could look like for a particular project. But a large part of that for us is the contractor end of things. And we did net zero roadshows.
So this is an education
It's an
based
education
committee.
A little bit more than that. So the educational bit is the roadshows that I was just about to mention. So we went around the country and we said, right, we're in Leeds. This is what the Leeds area are saying they want to achieve. You work here,
Yep.
London, Birmingham, Glasgow, wherever it is. But we were having the contractors speak to us and say, right, we understand now. We know net zero is coming. Destination without a map. How are we going to get there? So we know the destination. Can you help us as a partner? So we put some thought into this and we thought, well, yes, we can. So we created this scheme whereby it means we can share knowledge. They can use what we call a relationship development fund, bit of pot of money for them to do some work in establishing what their footprint is as a business. That's big tick number one, which is go away, measure, understand what your impacts are as a business. That's your starting point. Whenever I'm on a stage or in front of people, they go, where do we even start with this mine? Measure everything. Okay. And so committed carbon reduction partner is a whole package of things that we've put together whereby we can work with those who are committed, clue in the name, and say, well, look, this is what we can do to go on this journey together, because it's very much a journey, and we wanted to help as best we can.
Are you up for this?
Being part of the committee or part of the scheme? The committee? I'm
Committed.
Being committed.
Committed, not a committee.
We are committed. I was going to touch on deforestation. I don't want to go too far into it now. I think it will transgress a little too much. But I want to touch on deforestation. I spoke in my church yesterday about individualism and pride and how, as individuals, it can cause us great grief in life. And then also, yesterday at midday, I was watching David Attenborough with my little girl.
Right.
And it was Our Planet. And it was I don't know, have you seen the Our Planet with David Attenborough? He's basically, what I learned in 10 minutes, she didn't because she's only 20 months old, was that rainforests remove most of the carbon that is in our air. And mining, palm tree oil, palm oil, deforestation is crazy. Like, it's gone spiraling out of control. I think, what's alarming is because we are on this net zero without a map. And it's like running down a 100-meter track and not staying on the lines. So although we might do this, we might be doing the wrong thing. And what I mean by that is, I know there are companies out there which offset your carbon by planting trees.
Yeah.
But maybe we are spending too much focus. Obviously, as HVAC and contractors and manufacturers, we work in shifting energy. Perfect. What we're doing is brilliant. It's fighting that cause.
Yep.
Not to say that we're responsible for it, but if you are a big corporate organisation, one of these FTSE 100 companies or on the NASDAQ, and you're current, I'm not going to mention the names, but the big boys, and you're moving energy devices in non-insulated buildings, etc., and you're ignoring the fact that actually we're all eating products from palm oil, and our deforestation is going off the chain. We might not be sorting the problem. We might just be heating it, because mining metals is a big thing. I think the point I'm probably trying to get at is maybe people should be accountable for being stupid. Or making really unwise decisions. Unwise decisions, because that is the effect of what pushing net zero and also people not understanding net zero in commercial space can cause. It can cause brash, unrealistic decisions, which not only cost money, they're actually causing more harm to the environment.
Yeah, you're talking about unintended consequences. Best intentions, something's done only to find out that it's caused a problem elsewhere. So no,
but we can only do what we can in the moment we have.
And whatever little differences people make, they all add up. Doing nothing is really not going to help.
You know what? It takes as much energy to do nothing than it does something.
So
laziness is very tiring. Like it really is really tiring.
That's the thing I mentioned earlier, Jacob. Yeah, we're of a generation that has benefited from all of this release of carbon. We've benefited from it. Industrial revolution and all the technological advances that have come with that all the way through. And we're sitting here now as beneficiaries of that, especially of people who live in the west of the world. And but we now, the science tells us, the consensus of that scientific body tells us, right, we now understand that there's an issue that's been caused by that abundance of energy, you know. So now we know we've got to do things in a different way. That's how I would capture what net zero actually means. Is so we know the destination. So let's be laser focused on it. But you mentioned about trees. So there is a certain, you can be blinkered if you just look at net zero down the road, which is an energy and a carbon sort of measure. You can be blinkered if you don't see the biodiversity impacts and gains that could be made on that journey. The fairness in this transition, you know, we live in a society broadly where we could probably afford the heat pumps, and governments can help subsidise and do that sort of thing. There's plenty of other societies and countries in the world that don't have that benefit. So there's a fairness in this transition. All of these bits that I'm talking about here now are probably best captured by the UN in their body of work called the Sustainable Development Goals, which people can go away and look at. And that's 17 goals that says, look, how can we make this transition, but in a fair way for everybody, so that everyone's got something to eat, that everybody's got enough, all of those sort of things. And another thing I would recommend your viewers to go away and look at is, because then when you look at that big target, even then you go, what can I do? I'm one person here. There's something called the Good Life Goals. If you go away and look at those, that's a brilliant piece of work that says, actually you can, as one person, you can make a positive impact on all of these goals. So that's the
Good Life Goals.
Good Life Goals.
Okay.
Go and look those up. It's a really impactful piece of work.
And it does fit in with what we've been talking about as well. There's this whole thing about this.
So you're on the Good Life Goals.
I've read through it. Yeah, I've gone through it. Yeah,
Fantastic.
It made me go.
Give me one piece of advice from the Good Life Goals.
Okay, that was just when I was reading through those. That was when I was thinking about putting the actual heat pump in my house. So I was looking at what can I do differently within the house so I'm using less gas. Well, the most obvious thing for me, because I work for Mitsubishi Electric, was getting a heat pump. Yeah, it was a very easy step for me. And then the next conversations were having a chat with my wife and going, well, what could you do differently? And she said, well, let's have a look at the car situation. Yeah, that's one of the major reasons she changed over. It's not the only reason. There was monetary
involved. So you just
involved.
said it's interesting, because if I was to read that, the first thing I would say is, well, we could ditch the boiler, let's go air source.
Yeah.
Perfect. Where does that air source heat pump come from? Because if it's made in China or Japan and it's been shipped on a boat, which is burning carbon, and it's been made in Thailand and then it's been shifted here, so then I'm probably going to say, well, I'm going to want something that's made in the UK. So
Well,
would you
fortunately enough, we can give you that because we do manufacture in the UK. Very few people do.
So this is your Livingston plant, is that
That's
right?
correct, yeah.
Okay,
Yeah.
so what happens in Livingston?
It's a manufacturer of heat pumps and the other technology.
So air to air and air to water?
Air to air and air to water product. In fact, the very latest
Interesting.
R290 driven product, refrigerant based product.
Oh, wow.
Is coming
Is
out
actually
of
up in
Livingston.
Scotland?
Yeah.
Interesting. So your ESG score, Scope 3, is looking at transport of low carbon
It's interesting.
machinery and equipment. You actually tick that with a massive tick because
it's interesting, Jacob. When you look at the pie chart of where all your emissions are coming from, it's often a challenge we get, which is, well, build it closer, the emissions will be lower. Yes, they will, but that's actually a sliver. It's a fraction of the overall impact of a piece of product. If it's made in Japan, Thailand, or Livingston, Scotland, it's actually a very small tipping of the needle. Where the bigger tips come from is refrigerants. We touched a little bit on refrigerants earlier. I think for those of us who've been in this game long enough now, I think we're in a different place with refrigerants. The single refrigerant that did everything, and we all know the ones that they are, and we all had our favourite refrigerants as we've been through our careers. I think those days have gone now. You will have a refrigerant in a heat pump that is best suited to what you want it. Higher temperature, heat, ability to move heat around a building. So a building of a certain size, you will have multiple refrigerants in it. Now I know this is a personal thing, by the way, but the more I think about it, I think that's where we're going. The right refrigerant in the right heat pump to address what you've got to do. And if that means you've got 3 different refrigerants on one site, so be it. That's the most efficient way of going.
Do you not think with you building it in the UK, in terms of a biodiversity sort of standpoint, you're actually recruiting people in the UK?
Oh,
because I take it most of the people that work in that factory probably live down the road.
Absolutely, they do. Yeah.
So on a
employer Livingston,
because I know there's a lot of parts that have to come there, and they've come on boats. But the reality is if it is made in a different country, which I know nothing can, not all bits of equipment can always be built in the UK.
No, of course not. No.
But if you're in a market which is going towards net zero, because your EcoDans are great for commercial as well. I think up to 14 kilowatt you do. But your unit can go up to 14 kilowatt.
Yeah.
That works in commercial. But if someone would say, well, actually, let's look at something that's made in the UK, and you're kind of giving back to, UK employees. Yeah. It's and you're investing in the UK.
Very much so. And as a manufacturer, I wouldn't go as far as say it's a policy, but of course it makes sense to build this equipment and the solutions nearest to where the market is.
So for me, your life, it's called the life goals, right? Mm-hmm. For me, the EcoDan would fit. I've got an EcoDan, but I didn't really know that far because I didn't know life goals existed. But that ticks the massive box because the reality is you're investing in the country you're living in.
That's right. Yeah.
Rather than, I'm sure there are other manufacturers that have UK manufacturing.
Well, that's
but there are a large amount or a small amount of manufacturers which don't.
No.
They just have sales arms in the UK, and it's all imported goods.
And that's
but that's important for net zero, as in the approach, because you're saying, well, I drive an electric car and I've got a heat pump, but it's all from a country, it's all shipped in. The emissions to get it here, well, I'll never know what it is, but it's not my problem.
Yeah. So that's I mentioned earlier about embodied carbon, operational carbon. So you'll be able to go to our digital library, look up a product. Products are being added at a rate of knots into that library, and you'll be able to make some comparisons, even in our own range now.
Interesting.
You can say I could have a VRF running R32. I could have a VRF running R32 hybrid.
Then that's nuts.
I could have a chiller, and then you've got that
nuts.
data.
So the nuts thing about that is, normally when people want a spec, they want efficiency, they want adaptability, what it can do, what it can't do. You may actually have people buy because they say, that has produced less carbon dioxide to get here.
Yeah,
I want this
product.
And as a product overall.
Yeah.
So do you have like because the scope 3 on ESG is actually like, which I think you described it perfectly, is the emissions to get it to where it is.
Yeah.
You'd probably have a score for that.
That's all in there. It's clearly stated.
So somebody might prefer a product which is less suited for them, but has produced and produces less carbon, and they'll go for it because of that.
I said yes a bit quick then, but I don't think we're as someone who's close to this, and we've got a broader team. Our team in product marketing and our engineers have done a fantastic job at creating this body of information that the industry can tap into. But I don't think we're quite at the stage yet of the engineers and consultants, the end users, whoever it is, doing the full embodied carbon or whole life comparison. And I say yet. I'm going to underscore yet, because I think that could come down the line.
I think we're a long way away from that.
Should I have a 4-pipe chiller-based system, or should I have a 2-pipe hybridized VRF system?
Which produces...
Okay, one of my measures as to whether or not I go with column A or column B is the embodied carbon, and we're now in a position where we can have that discussion.
You can only do that if you've got that information. Yeah, which is probably going to cause a little bit of an interesting situation.
Yeah, I don't think we're at the stage yet where that's because not everybody's got all that data, so it's hard to compare. But what everybody's doing at the moment, and you as a contractor and every other contractor who's listening to this podcast must be seeing, and if they're not, it's coming down the line their way, which is big construction company A. They've made their statement to the market, to the globe, that we are going to be net zero by a period of time. We know that 2050 is the outside of that, but a lot of them are saying we're going to go quicker. And to understand the work involved to get to that net zero goal, they have to find out where everybody in their supply chain is on that journey. Some haven't even started, don't even know what the phrase is. Some.
Well, you mentioned embodied carbon, didn't you?
Yeah.
So I suppose your contractor is a massive, contributor to that.
Yeah, how they install it, the fixings,
How you
everything,
work.
that's all part
How
of
we
it.
work
Yeah.
and our attitudes towards it, because that, in essence, will have a detrimental effect of how it's installed.
Yeah, and you will be seeing this, that the larger mechanicals and construction companies are placing requirements on you to be on their site. You know, how you handle waste,
for sure.
what you bring onto site, how you take it off site, how it's handled, the certificates, paperwork that they require.
Well,
you to
that's
have.
starting to happen with some of the FTSE 100 companies and the bigger companies. We have ESG, but it's going to be really interesting for the next few years to see who fits into that space with the different, bodies out there which monitor and, a bit like Alchemist for the Safe Contractor. We have Safe Contractor. We have a few, and you kind of choose which one you go for.
Yeah.
But I suppose what would you class that as then, as a contractor? So embodied carbon is getting it there.
No, the embodied carbon is the thing itself. So it's all of the materials, the energy, and everything that went into that. Let's call it an Ecodan heat pump, because we've used that as an
to get
example.
it in that replaced state.
You then add your impacts.
Mm-hmm.
You had to travel there. You had to use fixings and everything to install that. So once that's installed and operational, that all of those embodied impacts should be measured, right? That then becomes part of the overall building. It could be a 40-story building. It could be someone's house, whatever it is. That building then, ultimately, we should get to a stage where we know all of the materials that are in that building, almost a spreadsheet. We know there's 1,000 kilos of copper, 2,000 kilos of aluminium, etc. And we go down the list. When that building is completely at the end of its life, or the individual piece of kit is at the end of its life, ledger comes back out. This is somewhere in the future a little bit, but
Data's
like
going to be the
get
future
that.
with this, isn't it?
Yes,
really?
data. We'd like to get those materials back, please.
Wow.
And I don't care whether they go to make another air conditioning unit or a heat pump. They could go to make a set of saucepans.
It's almost as if
material.
It's almost as if you've got a really good, efficient device which transfers energy from one place to another, but the sourcing of the materials have been massively detrimental to the amount of carbon it's produced. That will be a massive red flag. Yeah. Which, in a way, which I love as an engineer and a company owner, that it steps you away from some of the cheaper stuff.
Yeah.
Because it will be automatically, by default, removed from any tenders, and it will not be accepted because it doesn't fit within that category.
You would be able to glance down our list of ingredients. I describe it as you could bring all those.
It's like an organic cake. You have an organic cake.
Exactly.
Or you have a cake which is made on a pesticide farm, and they've used real low-skilled labour, and people haven't got nowhere to live.
I was going to go with the cooking one, but not that one, which was you can pull a pile of ingredients together and put the same pile of ingredients in front of me and put them in front of Gordon Ramsay, right?
Okay.
I can assure you he'll make a better job of that pile of ingredients than I will, right?
Okay.
Don't
be so hard on your cooking skills.
Yeah,
I'm
we're
sure
the
you know
Gordon
that,
Ramsay in this. We've engineered a product, a solution that we feel has got the right balance of embodied, operational, longevity. Because I mean, if you put a product in and you have to change it every 5 years, that's not going to help either, is it? It's finding that right balance, and then ultimately, when it really does reach the end of its useful life, recover those materials, make something else out of them.
You know we're involved in that, don't you?
What, Gordon Ramsay?
No, end of life.
Okay.
Yeah, that we have things in place for when
No,
the kit does come to the end of its
this
useful
sounds
life.
really caring, Ben. What?
Just
Please
part of it,
explain.
it's end of life size.
Please
isn't it?
explain
It's something
a
you've been
little.
involved with, so I'm going to get
When a piece of equipment ultimately is completely at the end of its life, we wanted to make sure that there was a route, a proper route for that piece of equipment to be recycled and handled properly. Now, so you can go to our website, you can find where these solutions are, but we'll offer you a route whereby you can be certain that that piece of equipment
That's amazing. That's amazing because
has had all the material recovered.
That ticks the box for lesser of mining for deforestation
Exactly that,
because you're reusing metals
And
rather
then-
than just buying a load of buying tons of steel and aluminium from a.
Yeah.
You will also find information on there. This is Japanese based, but I was very fortunate to see it some years back when I visited. 2 systems that we have. One's called hypercycle systems, and that is us working to understand how do we recover as much material from an end-of-life piece of equipment as we possibly can. And that enables us, the engineers in our team, to design new pieces of equipment, but with the end of life in mind, right? So they understand that right the way through. And then the next part of that process is something called green cycle systems. And then how do we make sure we bring the quality of those recovered materials up so that we can use them into new equipment and still
Actually,
meet our
you're thinking about it.
standards.
Yeah.
You're thinking about it.
Yeah.
Right.
What was it the same way? It's
I've got a couple of off the shoot questions for you. What's your dream car, Ben? Do not say a Tesla because it's
No,
not.
no, it's
You've
not.
got
No,
it.
no. Give me a nice Rimac. I'll have a go on one of those.
A Rimac.
Yeah.
Wow.
Yeah. Proper full on hypercar. But
That's
electric.
not the answer I wanted you to say.
What would you hope me to say?
I thought you'd be like a Charger, like a Dodge Charger kind of guy.
No, see, I've had the big motorbikes.
Rimac.
I've had really fast.
Isn't that one of the
motorbikes.
quickest cars?
Yeah.
Okay. That didn't go to the plan.
Sorry, apologies.
Martin, please don't.
Don't let him down.
I think it's hard to go past something like an Audi RS6 or something at state. It's every car you could ever want, isn't it? It's big enough, it's fast enough.
I like Martin's answer more because
It's of the right standard.
well,
And I'm
the reason I like it is because you are head of sustainability and you understand. This isn't putting you down, by the way, Ben. Of course, it wouldn't be. But you understand that as long as things are done correctly and properly, it will work. But if you go or become a green, mean, flag-waving machine, you could drive a Tesla and commit more carbon than than those that are driving an RS6.
Yeah.
I suppose if the RS6 is used recycled parts, although it's burning carbon.
Look, you
my
asked us
little
about a fantasy landscape. I'm never going to have one, so
No,
don't worry.
RS6. Oh, come on.
It's a fantasy landscape thing, but
I think people are more happier with V8s. I really do, but unfortunately, they create so much carbon.
you're right. So, it'll be electrified though. So I'm interested to see what's a future RS6 looks like.
I love it. Future RS6.
Yeah.
Yeah.
Okay. Well, let's just wrap this up. So the year is 2050. Go on, Ben.
I'm just very interested because you kind of went down the whole hybrid route and then you've taken a step backwards in my books.
Oh, damn! Shots fired. Okay. I do a lot of travelling. I need 50 to 50 miles MPG. The hybrid does that. The electric car, I can do 300 miles in one go. Unfortunately, there are people, hopefully there'll be people watching this that do a lot of driving that stop maybe once. Manchester to North Wales to Leicester and back in a day. You ain't getting the charges up in North Wales. However, my hybrid is great. It does 50 to the gallon. And it isn't a diesel. I think if I was going to go the diesel route, I think I would be taking the step.
What I'm interested in is it's still those steps in the right direction. It's still a step in the right direction. I did dig you about it, but it's still a step in the right direction.
If I was to have an electric car, I would offset it with a Land Rover Defender. That's
a great choice because Land Rover Defender is very rarely working. So that's absolutely spot on.
It'd be a visual museum piece. It wouldn't be driven, of course. It would just be there. But I would offset it with that to say, well, I'm hanging on. I'm hanging on.
I heard a great phrase recently, which was, it isn't a case of range anxiety. We all talk about range when it comes to electric cars. And I'm not an apologist for or promoter of electric cars. I have one. But, that's the way we're all going. So get used to the idea, Jacob. You will be in a fully electric car soon enough. It's not range anxiety, is it? It's charging anxiety. As long as you know you can charge when you need to the degree that you need to. And that's just the same as putting petrol or diesel in a car. If you haven't got a petrol station within the whatever miles it's telling you, you're going to have range anxiety. But you happen to be in a petrol car.
So to sort that out, Ben, you guys transfer energy to energy. What happens when heat energy gets turned into some kind of electrical energy, right?
Been done before, hasn't it?
Has it?
Yeah.
Well, that's how it's done now, isn't it? You burn something and...
but you're not without burning.
Piezoelectric.
Explain.
It's been around for a long time.
This is where I'm like, this is where the conversation has gone, because data centers, lots of heat, energy transfer.
Yeah, there's certain crystals you can work with that if you put energy into it, will actually produce electricity.
Interesting.
So,
okay.
It's all done on a small scale.
Okay.
But yeah.
Right, wonderful. Well, thank you so much
Pleasure.
for being on. That's a wrap, the Net Zero podcast, and tune in for the next one.
Cheers, Jacob.
Perfect.
Thank you, Jacob.
Thank you.